Okay, good evening, ladies and gentlemen, and welcome to this Saturday evening edition of the live class. And today we are going to discuss a topic which is a little, in the hypothesis testing, which is called ANOVA with Minitab. Okay. Anybody new person in the room right now today who is attending the session first time, just type me in the chat box. Um, we will welcome them and we'll start the session of this edition. Yes, I think is the chat on, guys? Can you just check? Chat on hai kya? Can you just give me yes in the chat box, everybody? If I'm audible? Huh, okay, okay. Yes, chat is on. Very good, very good. I thought the chat is not enabled. All right, fantastic, super. So, anybody new? I think generally new people will be on Monday, but anyone else? I think so. It's nobody. Okay, very good. Chalo, so let's start our journey with something called so let me just cover some of the basics, fundamentals, and then I will touch upon the core topic of the day today. Okay. So this entire topic is basically belong to analyze phase of the DMAC framework. Okay. So I'll be asking certain questions. Please give me the answer of that. Analyze phase, which is in the DMAC framework, the heart of the very important phase. So in this analyze phase, what we do basically is make a note of this. So we do fishbone analysis, which is cause and effect. Fishbone is nothing but cause and effect, or Ishikawa, right? After that, we do RCA, which is root cause analysis, or YY analysis, correct? So what we get in fishbone is nothing but we get the causes, or we can say the primary causes. In the RCA, we get root causes. Everybody see the sequence, okay? And after root causes comes the validation part. What is validation? Proving the root cause with the data is called validation. And in the validation, we have something called hypothesis testing. So today I'm going to touch upon hypothesis testing, and the topic of the day is basically a type of hypothesis testing, ANOVA. Are you clear, guys? Volume chota hai, volume kam hai. Okay, are you clear? So we are in the DMAC framework analyze phase. So in the DMAC, what we do, we find out the causes with fishbone. We find out the root causes with root cause analysis, RCA, YY analysis. And once we get the root causes, then we validate those root causes with hypothesis testing. And ANOVA is hypothesis testing ka ek part hai. So there are multiple hypothesis testing, out of which ANOVA is one. Are you clear which topic we are talking about in this entire DMAC framework? Just give me yes in the chat box. All the new member especially. So in Saturday edition, generally we cover a little advanced topic, but the best part is that I start with the basics and then I touch upon the advanced part of it. Okay, so that even new people also can easily connect the dots. All right, chalo. So let's talk about what is hypothesis testing. Quickly, let me just give you some idea about it. The people who already have given green belt hackathon, etc. How many of you attended green belt hackathon this week? Just give me in the chat box, because this topic was briefly covered in that as well. Yes, very good. Superb. Lot of people, huh? Amazing. So this topic was briefly covered. Obviously, the basic hypothesis is covered in green belt and the advanced hypothesis is covered in black belt level. So ANOVA is, so we'll touch upon the basics and then we'll touch upon. So a lot of people were there. So tell me, hypothesis meaning assumption, right? See, understand this. Now give me the answer, okay? In in this fishbone, okay, we find out the causes. with the help of our knowledge, our experience. Yes or no? We have man, machine, method, material, everything. With our knowledge and experience, we find out the causes. Yes or no? Everybody just give me yes, no in the chat box quickly. Yes. So all the man, machine, method, material, mother nature, machine, measurement, all these causes are according to our experience and our knowledge. Correct? Then comes the root causes. The next step is the root causes. When we ask the question why, again, that also happens with the help of our knowledge and experience. Yes or no? Just give me yes or no in the chat box. So just give me yes, no. Correct? So fishbone followed by YY analysis, both these tools, basically we use our knowledge and experience of our process. Now those root causes, the causes and the root causes are not validated with the data. It is still our assumption. It is still our assumption. We assume one of the fantastic classic assumption is experience, more the experience. Let me just fix this up. Okay. More the experience of the people working in the process, less will be the rejection and the defect. Yes, everybody, just give me yes in the chat box. That is your assumption. Yes or no, everybody? More the experience of the people, lesser will be the defects and the rejection. Yes, generally this is what we believe in, correct? It's a common understanding across industries. Doesn't matter which industry, right? And if the if the people working are less experienced, they are prone to make more defects, more rejections, more errors. So that's our assumption. What Six Sigma says, do not believe in anything, just collect the data and prove your point. And that's exactly what we do in hypothesis testing. Everybody clear? So our assumptions are basically we are proving with the help of hypothesis testing, with the help of data. Clear? Just give me C in the chat box. Basic understanding. Basic, very basic understanding. Very good. So there are two types of hypothesis. Null, we all know that, right? Null hypothesis, which is HO, which is statement of equality. We all know that, right? Statement of equality. Okay. And alternate hypothesis, which is denoted by HA, which is called as statement of difference. So first, null hypothesis will say statement of equality. Second hypothesis will say statement of difference. For example, in the case of experience, so null hypothesis will say experience, so experience does not make any difference. It's the same. Could be experience, so it's the same thing. And difference will say experience makes difference. We'll test the hypothesis. I'll give you another example. I'll give you multiple examples so that we can, and then we'll do the Minitab exercises. We'll do Minitab exercises. We'll do, then we touch upon ANOVA. When do we use ANOVA, etc. Okay. So let's take a case here. There are, okay, I want to test the hypothesis. I want to test the hypothesis. The hypothesis is the male, the male call center employees. Okay. Male call center employees, CCO, let's say call center officers. My assumption is that the male call center employees and female call center employees, there is a difference in performances. If let's say it's a call center, okay, it's a inbound call center, the calls of the queries of the customers are coming in, and I want to check what is the performance of the male call center officers and female call center officers. So is there any difference in case of the gender? I want to test this. So what I will do, I will collect some call data, the average duration of the successful call, and I will collect this data. So I will, let's say, collect some 15 data points here, some 15 data points here. So this is X bar M, which is for the male, and this is X bar F, this is for the female. So null hypothesis will say X bar, the average of the male employees call, is equal to average of female employees call. It's a null hypothesis. It's an equality statement. The alternate hypothesis will say average of male, employees calls, average call number, or the average call is not equal to the female average call. There is some difference. So gender is making a impact on the performance. ये हमारा assumption है. We want to prove this. So what we will do, we will collect the data. So what I'll just share one file with you guys in your chat. I'm just sharing one file. Just open that file quickly. Here we go. I'm just providing this file to you guys. Yes. Okay. ये रहा file. The file name is 2 sample t-test. Okay. पहले हम लोग experiment करेंगे. उसके बाद में I'll explain you what is this. Please open the file. The same file I'm sharing again. Again, for the new people, if you have laptop with Minitab installed into that, then only this file will open. Okay. Once you open the file, just let me know file open and we'll perform the test. And then we will, have you opened this? Just give me yes in the chat box. So the file will look like this. So we have got male CCO call center officers and female CCOs. Okay. Now, so we have taken some data here. So very small data points, 8 and 12. So the first impression is, even though we have got 8 data points of male CCOs and 12 or 10 to 12 data points of female CCOs, so number of data points are different. Can we still perform this test? The answer is yes, because we are comparing the averages. Are you understanding? We are comparing the averages of male CCOs and female CCOs. Yes or no? That's the reason if we have different number of sample size, still it will work. Are you clear with this point, guys? Because anyway, इसका पूरा average होगा और इसका पूरा average होगा, तो numbers थोड़े different भी होंगे, doesn't matter. Clear, everybody? Just very good. Let's perform because we are comparing two averages. What we are going to do is 2 sample t-test, which is one of the hypothesis tests. How do we do that? Go to stat basic statistics, 2 sample t-test. Stat basic statistics, 2 sample t-test. Everybody please click on this. Just follow this stat basic stats, 2 sample t-test. Click on that. You will have this window open. Just go to drop down. Now the drop down says both sample are in one column. If we would have both sample in one column, then we would have selected this option. Second option is each sample in its own column. And third option is summarize data. So we have each sample in its own column. Clear hai everybody? So we have to select each sample in its own column, the second option. Okay. So we have sample 1 and sample 2. So here we will select male CCO and the female CCO. That's it. CCO is call center officers. Everybody with me? So drop down may select the second option and then sample 1 male CCO, sample 2 female CCOs, and say okay. That's it. Once you click on OK, then you have to click on this Control Alt M, or you just have to drop this a little. You will find this. Okay, scroll up karo, aapko mil jayega ye. Or you can just click on this Control Alt M, which is sessions folder. आपने यहाँ पे क्लिक करने के बाद आपको ये दिखेगा. एवरीबडी गॉट दिस? जस्ट गिव मी यस इन चैट बॉक्स. Yes, very nice, super. Now just try to understand this. So what we are saying here, two sample t-test of male CCOs and female CCOs. So n is equal to number of data points. So the average is, so what we are doing here, 11.63 is basically X bar M, which is male CCO's average, and the female CCO's average is 12.80. Yeah, the process to get this window is this. Go to stat, basic statistics, two sample t-test. Stat basic statistics. So have you made this process and enter the data? Yes. Okay. Once you do that, click on OK. Once you click on OK, just press here. Below the window, now there is this option called sessions folder. Show sessions folder. Can you see here? I've just put my cursor there. Just click on that. You will find this. और थोड़ा scroll up करो. Data is not reflecting in two columns. The same file you are using, right? Okay, which Minitab version are you using? Are you using some different Minitab version than ours? Which Minitab version do you have? Okay now? Okay, fantastic. What about Labs? Labs कौन है? Who is Labs, by the way? Okay, 17 ही है ना? तो ओपन होना चाहिए. क्या प्रॉब्लम है? कैन यू जस्ट शेयर द स्क्रीनशॉट? आप ओपन करके देखिए स्क्रीनशॉट क्या दिखा रहा है. लेट मी नो. ओके, जरा स्क्रीनशॉट दिखाइएगा. तब तक जस्ट कीप एन आई ऑन द प्रोसीडिंग and share the screenshot. Okay, we'll resolve this. So X bar M and X. Now understand this. So average of male is 11 minutes. It is in minutes, by the way. Huh? So it is average call resolution time. Query resolution time is 11.6 and the female resolution is 12.8. So there is the mathematical difference, isn't it, guys? Yes or no, everybody? There is a mathematical difference, yes or no, everybody? Give me yes, no in the chat box. Very good. हाँ, आपको ना सेकंड ड्रॉप डाउन सिलेक्ट करो एंड सेकंड यूज द सेकंड ऑप्शन. Just click on the drop down and select the second option. I'll show you just once again. एक minute. Let me just explain him once again. So this is the drop down. Each sample in its own column. उसमें select करिए. ये आने के बाद sample 1, sample 2 आएगा, right? Now click in sample 1. You will get male CCOs and female CCOs. Click in sample 1. Just give me yes. Click in sample 1. Sample 1 पे click किया. Each sample in its own column. Sample 1 पे click किया या फिर sample 2 पे click किया. On the left hand side you will find a column. Yes or not yet? हाँ, that's what I'm saying. Sample 1 पे देखिए. एक मिनट. Let me do it once again for you. So drop down में second option each sample in its column ये किया. So sample 1, sample 2 आएगा. Now I click on sample 1, click on the blank space of sample 1. वहां पे आना चाहिए मेल सीसीओ, फीमेल सीसीओ. नहीं आ रहा है. Just give me yes or no. No. Okay. Just go back to the data. Can you see the data is there, C1 and C2 column as shown in my screen right now? Can you just go back to data? कैसे जाएंगे डेटा पे? यहां पे क्लिक करिए. ओके, डेटा पे ये वैसा ही है. मेल सीसीओ ग्रे एरिया में where the column name is there, male CCO and female CCO C1 and C2? Just give me yes. Yes. Just go to stat. Just do this entire process again. Go to stat, basic statistics, two sample t-test, okay? If you have selected pair t-test, that will not come. Select two sample t-test. Just follow me to the T. Two sample t-test. Select that. Just type yes. Okay. Now select the second option. Each sample in its own column. Okay. Then you click on sample one. Now it would come. Has it come? Just give me yes. आ गया? ओके एनीवे ठीक है, एक काम करते हैं, वी विल फिगर दिस आउट. नहीं, व्हाट शी इज सेइंग ऑन द लेफ्ट हैंड साइड इट इज नॉट कमिंग. एनीवे ठीक है, लेट्स लुक एट दिस. हम लोग अभी फिलहाल के लिए अभी समझ लेते हैं. ऑलराइट, ठीक है. आपका नाम डालिए ना. आई कुड नॉट अंडरस्टैंड योर नेम एक्चुअली. ओके शिवानंद जी. ओके शिवानंद जी, अभी फिलहाल के लिए हम लोग जस्ट फोकस ऑन दिस एंड दिस वी विल फिगर इट आउट कि क्या चैलेंज है आपके वो फाइल में. ठीक है, you are doing the procedure right, but let's focus. Okay, coming back to this. Now I was talking about this. Okay, now here the male CCO, the average was 11.63. Now remember, this is the most important mind blowing bulb on moment for everybody. And female CCO is 12.8. Is there any mathematical difference? Is there any mathematical difference? Yes, no? Everybody type yes or no in the chat box. Mathematical difference है कि नहीं है? Yes? ये very evident है ना? So it is not equal, right? There is a difference. So why do we go further? Simple, take the data, take the average, check the difference. So why are we doing this, checking this p-value and hypothesis testing? Why are we checking this? Type in the chat box. There is a clear-cut difference seen here, right? 11.63 and 12.80. There's a clear-cut difference of some 1.2. 1 minute and 20 seconds का कोई difference है यहाँ पे. Then why are we basically checking hypothesis testing? Type in the chat box. Very good. Okay. Manoj ji, what else? To see across the board. Okay. Good. What else? What else? Type in the chat box. Understand difference of fantastic. See, understand this. We have taken the sample and we want to check whether in the long term, in the population, in the long run, will there be this difference will be significant, statistically significant difference. Are you understanding? There is a difference. Agree. There is a difference between male CCOs and female CCOs. But if this difference is statistically significant for the population, for the long run, that is what we are checking. Are you clear with this? From the sample, we are inferring about the population. So this is the hypothesis testing is nothing but it is the inferential statistics. Do you remember descriptive and inferential statistics we discussed? Just give me yes in the chat box. Whatever we are doing for the sample, it is a descriptive statistics. And whatever we are inferring about the population, that is the inferential statistics. How many of you remember this? Just give me yes in the chat box. So here what we are doing, we are not only doing this mathematical checking of the difference, we are statistically, we are checking the probability that population में कितना difference होगा, will it be statistically significant. So now the p-value, check the p-value here. which is 0.044. Now, what is our rhyming? Type in the chat box. Which rhyming do we use in hypothesis testing? Very famous rhyming. Our, very famous rhyming. What do we use? Exactly. P low, null go. Very simple. Correct? Now tell me, P value is 0.0. P is what? 0.044. Is it lower than 0.05? Yes, no? Is it lower than 0.05? Yes, it is slightly, but yes, it is lower than 0.05. And whenever P is low, we reject null hypothesis. That's what we say null go. That's why we say null go. So we reject null hypothesis, which says, null hypothesis क्या बोलता है? X bar M is equal to X bar F. But P value is showing us otherwise. There is a statistical significant difference. That means the gender is making some impact on the performances. Are you clear? So with this P value, which is showing that this is significant difference. Now, yahan tak clear hai everybody? This is just a revision of what we have even studied in our green belt level. Just give me yes in the chat box. It's just a revision. Clear? Now, if you remember, if I have to draw the P value, graphically, how will I draw the P value graphically? If this is the male CCO performance and this is the female CCO performance, let's say. This is the average, which is what? 11.63. Now remember this is very, very important. And this is the female CCO average, which is 12.80. The intersection is the P value, guys. This area, which is intersection, which is P value. Now, understand this. This area 0.044 का मतलब है 4.4% area. Let's say if they overlap, it will become 100%. If they separate, the area will be lesser. The overlapping area will be lesser. Okay. So this area 0.04 meaning 4.4%. So this area is 4.4% right now. The overlapping area is. Okay. When this area is 5% and more, then there is no statistical significant difference. I will draw another drawing. Let's say imagine, let's say female CCOs are 11.8. So वो कहां पे आएंगे? यहां पे आएंगे. Are you understanding this? Look at this. If male CCOs is 11.6, imagine, and if female CCOs are 11.8, now they are very close. The overlapping area is very high. In that case, the P value will be greater than 0.05. In that case, the distance of the mean will be very, very low. How many of you got this? Just type yes in the chat box. So it's very simple. As we are going away, if the overlapping area is more than 5%, that means the difference is significant. If it is less than 5%, the difference is not significant. How many of you got it? Just type yes in the chat box. How many of you got it? So this area will be around maybe, 20%. I'm just giving you approximate number. This area is 4.4%. This area is more because it is closer. Are you clear with this? Just type yes in the chat box. This is a graphical representation of P value for your understanding. Clear? Just give me yes or no. If no, I will explain again. If yes, give me yes. Everybody, give me yes or no in the chat box quickly. Yeah, once again with example, I will definitely. सबको बाकी लोग भी बताओ फटाफट चलो. Everybody, समझ में आया तो यस, नहीं समझ में आया तो फिर से बोलो. समझ में आया ना? Very good, very good. So I will just repeat once again. Yeah, there are few people who are asking for the repetition. I'll repeat once again. Understand this. Look at my palms here. These are our data, the distribution. Clear? Now, imagine this is the average. The middle finger is the average. Okay, when we draw the bell-shaped curve, the center, the mode basically, the highest frequency value, let's say it's average, mean mode, is the same thing, normal distribution, right? Now imagine if if they are 100% overlapping, what does it mean? Both means are equal. Are you understanding? If they're 100% overlapping, everybody just give me yes in the chat box. If they are 100% overlapping, that means the mean of male CCO and the mean of female CCO is same. Yes? Everybody just give me yes in the chat box. Now imagine if there is a difference, they are separating from each other. Understand this? Now let's say the male CCO is 11.6, the female CCO is 11.8. Still they are very close. Hardly 0.1, 0.2 ka difference hai. Still the overlapping area is high. Overlapping area is nothing but a p-value. Still overlapping area is high. वो जब तक 5% नहीं होता, the difference is not statistically significant. Unless and until वो 5%, it's like, they're separating from each other, just 5% they are holding their hand, that's it. Before that they were hugging with each other. Okay, they were hugging with each other. Now they are just holding their small finger. 5% is just they are holding their hand. If, let's say, if there is a statistical significant difference, p-value is 0.00. That means there is no overlapping. That means there is a huge statistical difference. Are you understanding? Now, there is a very small statistical difference, which is less than 5%. So anything which is less than 5% is statistical significant difference. If you are making them a little distant, वो दूर जा रहे हैं, female CCO का average बढ़ रहा है, and they are going farther from the male CCO average. The moment they cross 5%, we can declare that yes, there is a statistical significant difference. Are you understanding? That's what, in this case, the p-value is 4.4%. That means it is less than 5%. So we can declare that yes, there is a statistical significant difference between these two processes. Are you clear? Just give me yes in the chat box now. Are you clear? Just give me yes. Clear hai? Everybody? Pramod ji, are you clear? Fantastic. Super. So just remember this. This is the simplest explanation of p-value. Clear hai? Super. Now, if we have 3 data points, now we have 2 data points, we are using 2 sample tree test. Okay. If we have 3 data points, what do we use? We don't use 3 sample tree tests or 4 sample tree tests. We use ANOVA. In that way, the second pick should be too far right. But I showed the other way. So this one is the closer one, and the first one is the too far away wala. Are you clear? Yeah. Clear, na? Very good. Now coming back. Now coming back to this, the same fundamental. If you have, let's say, first shift employee, second shift employee, and the third shift employee, if you want to compare 3 shift, okay, let's say if I draw like this, so overlapping area, again, this is the p-value, again we have to check. Okay, so any of the p-value, right? So the overlapping p-value, again the fundamental remains same, but it is not called as 3 sample t-test. This is called as ANOVA. When we want to compare more than 3 averages, more than 2 averages, basically, we can use ANOVA. ANOVA is analysis of variance. It's a short form of AN for analysis, O for off, and VA for variance. It is analysis of variance, ANOVA. Okay, let me give you a practical example and then we will discuss it further. So let me share this file with you guys. Just open this file and then we will discuss this. Okay, so I'm just sharing this file. And for for the advanced people, the people who are going for the black belt level now, okay, I'm going to give you a homework as well, okay, about ANOVA. Yes, it is analysis of variance. Okay, ये file को download करो and open it. Just once it is done, let me know. Open करके, ठीक है? Yes, everybody, have you opened the file? Just give me yes in the chat box. Super. Let's try to understand. Everybody just give me confirmation. Meanwhile, I'm just explaining you the data. Okay. So the data is, imagine there is a Mercedes, the service center, Mercedes service center is there. And there are 5 centers. They call them as zones. Okay. They call them as zones. So zone 1, zone 2, zone 3, zone 4 and zone 5. There are 5 service centers and they have collected the data. So for the first servicing, how much time every zone is taking. So here they have collected the data of first zone, which is the first service center. And so 5.3, 5.2, 5.4, etc. So this is the first service center X bar 1. Okay. Or X1 bar we can say. So this is the average. Then the second service center, this is the average of it. So they will take the average, then the average of the third service center, average of the fourth service center, and the average of the fifth service center. Software will do it for you. Okay, you just have to feed the data. That's it. Now, what is the null hypothesis? Null hypothesis says X bar 1 is the same thing. X bar 1 is equal to X bar 2 is equal to X bar 5. So all are equal. Null hypothesis says. And alternate hypothesis will say, alternate HA will say, at least one average is different. The statistically significant different than the other averages. Even one, even one average is different than the others, the test will fail. Okay. So we will just check, we'll do ANOVA because more than 2 samples, if you want to compare the means, we will go for ANOVA. So how do we do ANOVA here? Let's go to stat, ANOVA, one way. Stat, ANOVA, one way. Everybody follow this path. Stat, ANOVA, one way. What is one way? We are only comparing the zones. So we are checking zone wise, is there any difference in the means? That is what we are checking. So only zones we are checking. That's why we are calling one way. Okay. There is a two-way ANOVA, which I will explain someday later. If you have zone and a shift, there are 2 factors we are comparing. Zone wise as well as shift wise. हर एक जोन में हर एक शिफ्ट में क्या क्या डिफरेंस है. It's called two-way ANOVA. Are you understanding? Anyways, that will be a little advanced. We will do it sometime later. Okay. So here in the drop down, click on the drop down. It says response data are in one column for all factor levels. And second is response data are in separate column for each factor level. Okay. So here we have to select this. No, I think you have to select this one only, right? हाँ, तो response क्या है यहाँ पे? Lead time. And what is the factor we are testing? Is the zone. Response is lead time, and what factor we are checking is zone. So zone is the zone factor. In our earlier example of 2 sample t-test, the gender was the factor. We were checking male CCOs and female CCOs. Is the gender making impact on the performance? Okay. So right now we are checking, is the zone making impact? Just select zone and say okay. You will get this graph here. Everybody got this graph? Just give me yes in the chat box. Yes. Now just understand this graph first. The average of the first zone is this, around 5.3. Okay. And what is this? This is nothing but 95% confidence interval. So what we are saying is, with 95%, for the longer run, the zone 1's average servicing time will be between, maybe let's say this is 5.37 and this is 5 point maybe 22. So the average in the longer runs, right now the sample average is this 5.3, but for a long run, the average of the population, average in the long run will be between 5.37 hours and 5.22 hours. This is called 95% confidence interval of the mean, and there is a formula to calculate this. Clear? Have you understood this graph? ये बार समझ में आया? Just give me yes in the chat box. Yes, so range समझ में आ गई ये. First dot, center dot is the simple average of all the data points, and these two lines are confidence interval. It's a range basically. It's a range prediction. Okay. Now, by observing this, what is your observation? Tell me. What are you observing here? With this graph, what are you observing? Type in the chat box. Are you observing something special here? Zone 2 is taking a little more time. If you see here, just closely observe, zone 1, zone 2, zone 3, zone 4 and zone 5 more or less are very close to each other, but zone 4 thoda sa different hai. Are you understanding? Let's check out our p-value. Let's see our p-value, what it is showing. So let's click on our sessions folder here. Okay. So just scroll it up and check the p-value. 0.01, 0.018. So is it less than 0.05? Is it less than 0.05? Yes, no? Yes or no? P वैल्यू 0.018 यहां पे लिखा है, आपको दिख सकता है, यहां पे देखिए. करेक्ट? Is the range in the graph is 0.5%? No, it is not like that, Preeti. There is a formula to calculate it. I'll show you the formula. I'll give you the formula of that. Okay. There is a session on CI, confidence. मैं आपको वो दोनों भी ना आपको होमवर्क देने वाला हूं. Please go through it. Now you guys have done your green belt, like, तो थोड़ा सा डीपर जाने की जरूरत है अभी. So I'll give you the deeper वाला thing. Okay. हाँ, how do we get the p value? Wow. So हाँ, पहले मेरे सवाल का जवाब दो. Is it less than 0.05? Is it less than 0.05? Yes. So when it is p value is less than 0.05, according to our rhyme, P low null go. So we reject null, which says statement of equality. So we have to reject null hypothesis, and we have to say that there is a statistical significant difference between at least one value, and from the graph we can make out zone number 2 has a more average. Now let's do one thing. Let's remove zone number 1. Let's remove zone number 1. Okay. Sorry, zone number 2, not zone number 1. Okay, चलो, go to the data. मैं zone number 2 को delete करके देखता हूं कि क्या फर्क पड़ता है. Okay. And इसको ऊपर पेस्ट करेंगे. ठीक है. Cut the cells and paste the cells. Okay. Replace all active cells like this, and then we can delete all these things. ठीक है. तो मैंने क्या किया, जोन 2 को रिमूव किया है एंड बाकी के जोन को ऊपर ले लिया. ठीक है. Now I am performing the same test. You can also try this out. Just delete करो उसको और ऊपर वाले को कट पेस्ट करो ऊपर से और नीचे वाले को delete कर दो, ठीक है? Now just stat basic statistics. No, it's ANOVA, not two sample leaders. Stat ANOVA, one way ANOVA. Okay. हाँ, 0.018. Very good, very good. So it's not p-value of zone 2. It's the overall p-value is less because the zone 2 average is different. It is showing the significant difference. Statistically significant difference it is showing. Okay. Now, let's do this test once again and click on OK. Now look at this. After removing zone 2, so we have only zone 1, zone 3, zone 4 and zone 5. Okay, so there is not much difference we can say, but go again with the, with our sessions folder, scroll it up. Now check the p-value, guys. Now check the p-value, which is 0.86. That means all the zones are like this. If I were to draw like this, they are overlapping very close to each other. And the area overlapping is 86.4%, which is very high. So there is not much significant difference between the averages. Very less difference between these averages. Are you understanding this? Clear hai? Just give me yes in the chat box. So I've drawn these graphs, 3 to 4, bell-shaped curves, and they are very close to each other, overlapping 86% area. If the bell-shaped curve area is 100%, all they are overlapping to each other is 86.4%. That's why the p-value is 0.864. So very high overlap, p-value is high. Now, after removing zone number 2, there is not much statistical significant difference. They are performing equally. So zone 2 में हमें improvement करने की जरूरत है. We need to reduce the lead time of zone 2. Are you clear with this? Just type yes in the chat box. And this procedure is called ANOVA. Clear? Super clear? Just give me yes in the chat box. This is the simplest explanation of ANOVA. Otherwise, people make it so difficult to understand. I've given you a very practical understanding. Super clear. Very nice. Amazing. Now, the people, how many of you want to go deeper into the concept? Just type me in the chat box. How many of you want to go deeper into the concepts? Okay. Now we have lot of tools already given, right? Everybody wants. Fantastic. That's why you are here, correct? So I have a small request. Okay, I'll show you. So there are a couple of sessions I would like you guys to go deeper to understand ANOVA deeply. Okay. Statistically coincide this test. Please repeat. Yeah, I'll repeat again. I'll repeat again. Okay, just listen to me just here. Now everybody in your LMS system, now in your LMS system, we have something called Master Class Archive. Everybody knows about Master Class Archive. Just give me yes in the chat box. Prasanna ji, I will answer that question. Yes, everybody knows Masterclass Archive is the collection of all our recorded sessions. Like today's session is being recorded, that will be put in Masterclass Archive. Clear? Now, understand this. For understanding ANOVA deeply, the first session I would like you guys. So when you go to Masterclass Archive, okay, when you open any of the session, on the left hand side there is a search option. If you can open it right now with me, just do this exercise. On the left hand side there is a search option. In the search option, okay, just type p-value. Okay, so there are p-value demystified. Can you see here? What is this p-value? P-value demystified, hypothesis testing, and p-value decoded. Can you see this on the left hand side? The moment I type p value, just give me yes in the chat box on my left hand side. Okay. If I click on p value demystified, this one, I'm opening this, which was done on 16th of what is it, November. Okay. So what I'm doing, I'm just copying this, इसको copy करके I'm just putting it in our chat. Please go through this as a homework. How to calculate p value manually. Clear, everybody? Just type yes in the chat box. How to calculate p value manually. Are you clear? Just give me yes. तो ये आपको लिंक है, and I have shown you in the masterclass archive. Go to the search folder and type p value, and the title is p value demystified. That means decoded, explained. ये session देखिए. It will give you immense clarity how it is calculated manually. You can calculate it manually as well. Clear? Now, again go back to this. Just close this. Again go back and type now here ANOVA table. ANOVA, yes. Decoding ANOVA table. Can you see here? Decoding ANOVA table. Just click on this session. I'm just clicking on this session. Decoding ANOVA table, which was done on 11/5/24. Okay. So this is the second. It's a master class of ANOVA. It will give you very deep understanding of each and every item there. I'll show you. Okay. So have you taken down this? I have already given you this. You can just copy and paste it, or you can search in the masterclass archive as well. Okay. Why I am showing you this? Because let me share with you. Okay. In these two sessions, what are you going to understand is this. Let me share my screen once again with the same ANOVA, what we have done. Now this is the entire ANOVA table. So this actually is called ANOVA table. Can you see this? This is called ANOVA table. And this ANOVA table is decoded with calculation, with Excel sheet calculation, manual calculation. And in the first video, which I told you, how to calculate this p value manually with the help of simple tables, that I have explained you. Okay. So this is, you can see a DF is for degree of freedom. ADJSS meaning adjustable sum of squares. ADJMS meaning adjustable mean square. Adjusted, not adjusted mean square. Then there is a F value. We calculate the F value, which is nothing but this divided by this. Okay. So ये सब उसमें calculation करके clear किया हुआ है. Are you clear that? Just type yes in the chat box. Please show once more how to filter. So it's very simple. Let me go back once again. Listen to me very carefully. The moment you open masterclass archive, on the left hand side, below this, on the left hand side, there is a search option. यहाँ पे click करेंगे तो search bar आएगा. वहां पे आपको type करना है ANOVA table. ANOVA table. Okay, you can see here decoding ANOVA table. यहाँ पे देखिए. Adjusted mean square. Okay, that's what I'm saying. This I've given you already a video. Please go through the video. All right, and learn how that is calculated. Okay, अभी मुझे आधा पौना घंटा लगेगा वो पूरा calculation समझाने के लिए. So please go through this video. It's very simply, very clearly explained. Excel sheet calculation भी उसके नीचे, वीडियो के नीचे Excel sheet calculation. Can you see here? This is the video, right? यहां पे देखिए एक्सेल शीट कैलकुलेशन है, स्टैटिस्टिकल टेबल है. ये टेबल आप डाउनलोड कर सकते हो. ओके, मिनीटैब का फाइल भी दिया हुआ है, एक्सेल टेम्पलेट, एक्सेल कैलकुलेशन भी दिया हुआ है, एंड स्टैटिस्टिकल टेबल भी दिया हुआ है. ठीक है. यस. एडजस्टेड मीन स्क्वायर, एडजस्टेड सम ऑफ स्क्वायर, ये सब है उसमें. ओके, एक बार गो थ्रू दैट. इफ नॉट अंडरस्टूड, वी ऑलवेज हैव अवर मेंटर्स नंबर. Yes, but please go through the homework and then ask the question so that you can ask the quality question. ठीक है जी? Clear everybody, and save this number where you can connect for any kind of doubts in the future. Okay, so I'm open for question answer. Any question you have, please let me know, and let me check out some of the questions. हाउ डू वी स्टैटिस्टिकली कंक्लूड द टेस्ट? तो मैं वो एक बार फिर से दिखा देता हूं कि हम लोग स्टैटिस्टिकली कैसे कंक्लूड करते हैं, ग्राफिकली, मतलब ग्राफिकल एक्सप्लेनेशन उसका क्या है. दैट्स व्हाट एक्चुअली यू आर आस्किंग. सो दिस इज अ क्विक डेमोन्स्ट्रेशन ऑफ दैट. ओके, इट इज सेम थिंग बेसिकली. सी, इतना सिंपल एक्चुअली कौन से भी टेक्स्ट बुक में आपको ये नहीं दिया गया है. पी वैल्यू इस प्रकार से आप रीड करो. यू नो, दे जस्ट टीच यू पी वैल्यू लो, reject null hypothesis. That's it. Okay. We are going just one step further. So here, when we have these two samples, okay, right? So the same thing applicable for two samples, same thing applicable for the three samples. Let's say there are three samples like this. So this is the total overlapping area of all the three samples. So this software basically calculates this overlapping area. 3 sample, 4 sample, 5 sample. Imagine one sample is a little farther away like this, like our 4. So here, understand this. This is sample average of 1, 3, 4 and 5. Let's say 1, 3 and 4. And this is the sample number 2. Was it like that in ANOVA? Just give me yes in the chat box earlier. Yes, everybody? Earlier it was like this, correct? So what is the overlapping area? You can see the overlapping area is this. This is the only overlapping area. Total overlapping area is this. So this area was 0.018, which is nothing but only 1.8%. It is 1.8%. What is 0.018? It is nothing but 1.8%. करेक्ट? इसको मल्टीप्लाई करो 100 से ना, 0. इसको मल्टीप्लाई बाय 100 करो, यू विल गेट 1.8%. परसेंट में मिल जाएगा, राइट? सो 0.018 meaning 1.8%. So in this case it was 1.8%. And how much we want? Minimum 5%. If this would be minimum 5%, so that means this is not statistical significant difference. Clear? We shared with 5 samples. Yeah, the same thing. Okay. So now then we remove the zone number 2, and now all the other samples are very close. Overlapping was very high, which was 84%. So other zones were very close to each other. So not much difference between all the other zones. Only zone 2 mein kuch gadbad hai. So we have to go there and check what is wrong happening in zone 2, and we have to improve their performance. That's how we do it. Clear, everybody? So it is the overlapping area between basically these things. Okay. How do we decide where to use one-way ANOVA and two-way ANOVA? So this is one-way ANOVA because we are comparing the zones here, okay, with each other. What is two-way ANOVA? Let's say you want to compare zones and the shift, both factors. There are two factors you are comparing, right? So here right now, y is equal to function of x, one only. That is called one-way ANOVA. If you are checking y is equal to function of x1 and x2, where x1, let's say, is zone, and let's say x2 is, let's say, shift. So zone may be first shift, second shift, night shift. Zone 2 may be first shift, second shift, night shift. Zone 3 may be first shift, second shift, night shift. So now we are not only comparing zones, we are comparing shift wise as well. That is two-way ANOVA. दो फैक्टर हम लोग चेक कर रहे हैं, right? Like for example, temperature, impact on the temperature on the hardness. Okay, that is one way ANOVA. Hardness is my y, impact on my temperature on my y. Now I am checking impact on my temperature and pressure on my hardness. That is the two-way ANOVA because I am testing two factors. Clear, Pramod ji? Just give me yes in the chat box. Concept clear hai? One way is for the one factor, two ways for two factors. What happens if any one of the bell curve is not at all overlapping? So that will be shown as statistically significant, like the second one. Okay, second one to 1.8% to overlap कर रही थी. Imagine it is 0, so a p value will be 0.00. That means, see, anything less than 5 we have to p low null go, reject null hypothesis. Very simple. 5% से रिजेक्ट कुछ भी हो, कम कितना भी हो, 0 हो या फिर 2% हो, 3% हो, 4.9% हो, 4.99% हो, we have to reject it. Yes, all together. Yeah. So that means there is at least one data point, and we can figure out now from the graph. We can figure out, like in the earlier case, we could figure out the second zone was a little farther, right? So we can figure out that this zone has a problem, which is statistically also proven that it is a significant difference. Okay. So in the long term also, it will give you the same significant difference. Okay. How to represent the zone 2 not performing similar to other zones? Like, is it through exporting files and directly sharing the Minitab files? How to represent that zone 2 is not performing? So see how you can show this. For example, let me go back to my ANOVA file ना. अगर आपको वो दिखाना है कि zone 2 ही नहीं perform कर रहा है, just go back to the file, go back to the graph and show them both these graphs. Okay, understand this. Show them both these graphs, graph number 1 and graph number 2. ये ग्राफ नंबर 1 एंड ग्राफ नंबर 2 दोनों को भी दिखा दीजिए साथ में. ओके, ये वाला राइट में डाल देता हूं मैं, एंड ये वाला फर्स्ट में. सो इफ यू शो दिस ऑन अ पावर पॉइंट प्रेजेंटेशन, okay, yes, that zone 2 is, can you see the zone 2 physically also? Then you can just go back to this one, उसको कॉपी करो पहले वाले को. okay, this one, एनालिसिस ऑफ वरायंस के टेबल को कॉपी करो एंड पी वैल्यू को हाईलाइट करो. सी द ग्राफिकली ऑल्सो इट इज शोइंग इट इज गोइंग अ लिटिल हायर, एंड पी वैल्यू इज ऑल्सो प्रूविंग दैट there is a statistical significant difference because the p value is 0.018. Now after that you show again. Now see the, after removing this, okay, the zones, there is no much difference between graphically as well, and statistically also p value is showing the same thing. Okay, yes, very good. So once we figure out that zone 2 is different, are we abandoning the hypothesis totally? No, it's proven, right? So that means there is a statistical significant difference. So what we are doing is, so, and we understood the culprit is zone 2. So the next step is, so see, what are we basically trying to check? Zone wise there is some difference in the performances. ये हमारा assumption था, which is getting confirmed with this hypothesis testing. That was our assumption. So what we are doing is, we are improving the performance of the zones which are lower performing, and then we have to do the statistical hypothesis once again. Okay, are not showing significant differences. Do we proceed with that information? So that means, see, what is the conclusion here? Zone 2 is required some focus, some improvement. That is the conclusion. So उसको improve करो, उनको नीचे लेके आओ, उनका service time नीचे लेके आओ. Again compare this 5 zones together, and then we can prove to the management that, see, earlier it was significant difference, now it has brought down to very insignificant, very, very less difference now. That we can do. Clear? Just give me yes in the chat box. Super clear है? So ये homework दोनों भी videos आपको देखने, how to check the p value manually and the ANOVA table वाला. Will you do this? How many of you will do this before our next session? So Monday से पहले, before our next Saturday वाला session. तो एक हफ्ता है आपके पास. Clear? Very good. Fantastic. Super. Yes. So now you guys, green belt holders जो है, please go to the next level. Go deeper into the concepts. Okay. So again, before we close the session, we have the yellow belt session on Sunday, which is tomorrow. Please, send your referrals to get your 40% referral bonus. Okay. Yeah. So HA is valid. Yes. Alternate hypothesis is valid. So we correct zone 2. Yes. So zone 2 को फिर से नीचे लाने के बाद, average नीचे लाने के बाद सबका ये equal हो जाएगा. So null hypothesis will be valid then. Okay, उसके बाद में null hypothesis will be valid. Okay, Minitab issue, yes. So एक बार वो screenshot, so is it happening to two sample t test वाले में भी यही प्रॉब्लम आया था क्या? टू सैंपल टी टेस्ट में भी यही प्रॉब्लम आया था. ओके, एक बार एक काम करिए, just try, understand this, just try some other sample files which we have already there in our LMS system. Okay, if you are finding same problem in all the files, please communicate on our mentors number and we will sort it out. ठीक है? हाँ जी, हाँ प्रसन्ना जी, आपका क्या था पॉइंट? में भी एक मिनट ऊपर गया, कॉपी कॉपी पेस्ट कर सकते हैं आप थोड़ा सा नीचे? कैन जस्ट कॉपी पेस्ट. हाँ, हाउ डू यू नो द सैंपल साइज? ओके, सैंपल साइज. सो सैंपल साइज के लिए इफ यू रिमेंबर द टी टेस्ट और द एनोवा हमें ये पावर देता है इवन इन लेस देन 30 डेटा पॉइंट. सी, इफ यू रिमेंबर अवर थंब रूल, व्हाट इज अवर स्टैटिस्टिकल थंब रूल? सैंपल साइज मिनिमम कितना होना चाहिए? एवरीबॉडी टाइप इन चैट बॉक्स, व्हाट शुड बी अवर मिनिमम सैंपल साइज? टाइप इन चैट बॉक्स एवरीबॉडी. For any statistical purpose, mean, mode, median, hypothesis, regression, 30 data points, right? Okay. Now, if we get why 30 data points, it is naturally proven that the moment the sample size reaches to 30, it gains the normal distribution, the Z distribution. Z is the normal distribution. But if you don't have 30 data points, if you have lesser data points, that's where our T distribution comes into picture. Okay. So here, if you see our two sample t test wala example, okay, two sample t test wala example, Prasanna ji, we had less than this. Okay, what you can say, क्या बोल रहे थे, less than 10 or 12 data points, right? For two sample t test, so t test gives us the what you can say, gives us that freedom कि आप less sample size में भी काम कर सकते हो. So that advantage we get with the t-test. Okay, whenever you cross the 30 or 50 or 100 data points, you can go for the z-test because z distribution is good enough. All right? Yes. So AIAG, that is for the gauge R&R. 10 into 3 into 3 is for the gauge R&R के लिए वो study है. Okay. What 30 data points I'm talking about is, okay, now understand this. ये 90 कब होगा? ये 90 कब होगा? Actually it is 10 into 3, 30 only. 10 into 3, 30 only, but we are actually checking 3 people. That's why it is 90. So actually, 30 data points ही है. But we want to check the difference in reproducibility. Are you understanding? Repeatability के लिए 30 data points is good enough. For reproducibility, we want another 3 people, right? So we want multiply by 3, that becomes it 90. So 30 का thumb rule याद रखिएगा. Clear है? Yes? Super? Very good, very good. Amazing. चलिए, so that's it from my side. थोड़ा सा heavy, थोड़ा सा advanced session था, but go through the recording once again. 2 videos मैंने भी दिए हैं. Go through that, understand it. Any question, ask on the mentors number, okay? And share your, share the link of the yellow belt session to our referrals and get your 40% referral bonus, okay? So see you day after tomorrow, Monday, with a fresh topic, with the same enthusiasm till the time. Keep learning, keep growing. This is Dinesh Patel signing off. Thank you very much.